Ladies and gentlemen, I'm happy to open up this webinar. The webinar is all about the UltraMap version 6, our software version, our software workflow system which processes the UltraCam imagery. During this webinar we will talk about the new features and we will demonstrate the new features, and then we will open up the floor for questions and answers. The speaker of today will be Bernhard, our application specialist. He will be doing the demonstration of the features, and myself, I will be open up this webinar by discussion or by presentation on UltraMap in general. If you have questions during the webinar, please be so kind and type them in the Q&A pane of the software, and we are happy to answer them after the sessions online here in this channel. In my introduction, I will talk about UltraMap in general, the history of UltraMap and the concept of UltraMap, and Bernhard will later do a deeper dive into the new features of the version 6, and he will run the demonstration of the new features. UltraMap has a rich history and delivers a constant stream of innovation to our customers. It all started in the year 2010, where we introduced UltraMap version 1 with the raw data processing and a very flexible and intuitive distributed processing. A year later, in 2011, we launched UltraMap version 2, where we introduced the monolithic stitching as part of the raw data processing, for example, and also we implemented highly innovative features on the radiometric color balancing of a project. Again, a year later, 2012, we went into the ortho and 3D world. So we added features to UltraMap, how to generate 3D point clouds and how to derive surface models from it, and then the imagery and the surface models and the terrain models we are used to process DSM ortho and DTM orthos. And in 2016 we launched UltraMap version 4, where we also worked on 3D data, where UltraMap Studio was implemented, and again a rich feature set on radiometry and 3D data was implemented. The next step in 2020 with the software version 5, we again worked on new feature sets for the 3D data handling. We implemented the terrain model as an exportable product out of UltraMap, and then with the announce of the fourth camera generation, we also implemented the adaptive motion compensation in UltraMap, which is this highly innovative feature how to deal with any kind of motion blow, let it be translatory, rotational, and also image scale, which we announced and introduced into the market with the fourth camera generation. And then, as of this year, 2023, we are announcing the next big step of UltraMap, the UltraMap version 6, where we implemented a rich feature set using machine learning algorithms all around the water handling, so that this feature set enables our customers to achieve better results in a faster way and with less manual effort and a higher quality when it comes to the handling of water areas. The customer preview of UltraMap version 6 went out at the beginning of this year, and now during this month we expect to release the first official final release of version 6 of UltraMap. When we talk about UltraMap, it is all about the transformation from the raw data imagery to high value information. What we were always striving for is to implement the whole quite complex process of image treatment and image processing in a very simple and intuitive user interface. That is rounded up by a highly intuitive workflow following the natural steps how to deal with the imagery from the raw imagery to the high value information. And with all that, we are achieving a software system which requires minimal training effort and delivers exciting results and is highly automated, so the results you achieve it in a highly efficient way. One key feature of UltraMap, which is underlying since its first release, is the distributed processing, which you can configure very flexible so that you can grab all the compute resources you have in your company in a very efficient way to speed up your processing. What we are also always taking care about when we develop UltraMap is the backward compatibility with the whole UltraCam camera lineup. So even when we are developing now a new feature in UltraMap version 6, which comes out in 2023, that feature works for all the older UltraCam models, down to its first one, UltraCam D, which was launched many years ago. So all camera models instantly benefit from new versions of UltraMap, regardless when you did buy this camera model. And then, as each software system has its questions and each customer needs its specific training, we are striving for a world-class support which is available 24/7 all around the globe. For purchasing the software, we developed two different models. The first model is what we call the proprietary licensing. This is the classical way to own the software. That means you buy the packages you want to own, and with the purchase, you own these software licenses forever. If you want to benefit from the ongoing software development, you can either purchase software upgrades from time to time, or, and that is the cheaper solution, you put your software under a software maintenance contract, and with that you will get all the new releases automatically and you can install it as it benefits to you. So that's the first model, and the second model is what we call a subscription model. Here you buy the right to use the software for a limited period of time, usually several months, but we are highly flexible here, and you can cherry pick the modules which you want to use for this period. Most customers are using the subscription model as an add-on to their existing installation. So if you, for example, have a big job to fulfill and you need more processing power, then for a few months you add additional licenses, additional cores to your already existing software installation, and that gives you the power you need. Or another example, you are up for a 3D job and you haven't purchased our 3D tin module, but you need it, then you can also add this module for a time-limited period to your existing installation. UltraMap, with all the module, supports the full photogrammetric workflow, starting from the project setup to the area triangulation, to the radiometric adjustment, to the dense matching, to the terrain filtering, which gives you the DSM and the DTMs. We support also projection in different ways, and then we have a full 3D module which gives you the 3D tints. The whole UltraMap suite is organized in several modules following the natural workflow how to deal with the data. The first step is when you come with the data units from the plane, full of great imagery, raw data of course, then you ingest it into your computer system and you use the first module, the UltraMap Essential module, and here all the radiometric and geometric corrections are applied, and as a result you can export the imagery in various formats. The next step in the workflow would be the UltraMap area triangulation module. This is where the whole exterior orientation is being calculated. Also here you have export options to deal with other soft copy systems. Following the UltraMap workflow after the area triangulation, the dense matcher kicks in with the UltraMap dense matching module. It's all about 3D data generation. So in this module the point cloud is being generated, and from the point cloud a surface model and a terrain model is being derived. And again here you can export these data sets for the handling in other soft copy systems. Again, the next step in UltraMap would be our UltraMap Ortho pipeline. Here the already existing data, the imagery and the terrain or surface model is overlaid in a projection, and that gives as a result either a DTM ortho when the DTM is used as the underlying module, or the DSM ortho image when the DSM is used as an underlying data set. Again, all of these data can be exported. And then last but not least, the 3D tin module would be next in line. This is where a 3D tin is being processed out of the already existing data sets, and that can be exported in various data sets for further treatments. After this overview about UltraMap in general, I am happy to hand over to Bernhard. Bernhard will explain and demo the new features of the UltraMap version 6 in a greater detail. Bernhard, the floor is yours. Thank you very much.
Yeah, thank you, Alexander, and welcome now to the second part of the webinar, where I would like to speak about the new features of UltraMap version 6 in detail. So I would like to present 3 new features which we have now available. So the first one is the True Pixel Processing, the TPP. Then we have the enhanced ortho module performance. And then finally, I would like to talk about the water handling features, a big group of new features available. So the first new feature is True Pixel Processing, TPP. TPP is a new proprietary method for post-processing of raw images. These raw images, that is the level 0 data as it is captured by the camera. And that data is processed in an automated step to level 2. Level 2, that is the data stage which can be imported into UltraMap Studio for the further photogrammetric workflow. TPP provides a lot of benefits with regard to image sharpness, image brightness, and overall image quality. TPP is applied automatically to the data in the processing, and the user does not need to change anything, and the workflow or the user interface does not change for the user. So it is a fully automated process, now available for the recently launched UltraCam Eagle 4.1 and coming soon for the other cameras of our 4th generation, so the Osprey 4.1 and the Condor 4.1. The next new feature, that is the enhanced ortho module performance. So throughout the years we collected a lot of feedback, and also now with the development of the new features of the water handling, we have seen the need to adapt various components of the ortho module to fulfill all the needs of the user to work and interact with the data. This new software version provides now a faster loading of the data, faster viewing, and then also acceleration when saving big project files. Then also when exporting the data, there are a number of improvements. On the one hand, more efficient handling of the memory consumption of the processing PCs, and on the other hand, some flexibility when exporting the data. When creating the map sheets, there are no limitations for the size of the map sheets. And then we have optimized the user interface of the ortho module. On the one hand, this includes a regrouping of all the tools that are needed and all the tools that are available in the ribbon. And on the other hand, we have reorganized the control of the various data layers. So this allows now to switch on and off layers in a very different way, also overlay and combine information, and therefore get much deeper insights into the data than before. I will show that in a little bit more detail in the live demo afterwards. And then there is this big group of new water handling features. The water handling is an essential part in the workflow, which can now be addressed by the user in a very efficient way. So on the one hand, when creating single images, these can benefit from that feature, because color balancing is already aware of the water. And on the other hand, when producing ortho data, so let's say DSM, DTM, DSM ortho and DTM based orthophotos, all these products will also take advantage of the water handling. So to enable all these processing steps, we have integrated an automated classification of water into UltraMap, and based on this automated classification, the water height of the single water bodies can be derived automatically. Then, using all that information, the software can do automated color balancing on land and on water. So the color balancing algorithm is fine-tuned to the specific land cover of the scene. And using the knowledge about water, we can also do a much more robust generation of the DSM and the DTM. So in the end, the final products are now much cleaner, and you can create a homogeneous orthomosaic and on land and on water, as it was not possible to do before. So let's have a look at this workflow in detail. The first few steps of UltraMap version 6 have not changed compared to version 5. So first, the processing of the raw data, the level 0 data to level 2, is done in the automated way with RDC. Now with using the new TPP. And then based on that data, the project can be created automatically in UltraMap Studio. GPS data can be integrated, and ground control points can be used as well. Then type points are extracted automatically, and all that information is then combined in a bundle adjustment to calculate precise exterior orientations for all the images. Then in the next step, the water classification is done automatically. So this results in a water mask which can be visualized, inspected by the operator, and that can also be edited by the operator. And then based on that water mask, the software is calculating automatically the height of water bodies, and this is then also available for the operator for inspection and modification. So the water mask and the water geometry editor both are working on the low resolution of the DSM, and that allows to, on the one hand, get results very quickly with a short amount of processing time, and on the other hand, to be able to visualize and interact with very large amounts of data, so very huge project areas can be handled in one go. And then additionally, we offer an import for an existing water mask, and this water mask could be either from previous UltraMap projects, or this can be from an external source. So the existing water mask from UltraMap projects, this is available for the use case that a project area needs to be reflown multiple times. So if there is a project area flown every few months or every year, then you can invest quality control time into the first iteration of this project, create the water mask with a high quality level, and then reuse that water mask throughout all the other iterations of the project. On the other hand, the import for the external vector mask, that allows you to import data from a source like, let's say, OpenStreetMap or similar, or you can use vector data which is provided by your client, and that can be imported into UltraMap and override the water project files available there. The next step of the processing is the automated color balancing. This is trying to compensate for any brightness differences in between the images, and also some other differences. So effects of, let's say, changing date or time, changing weather conditions, changing camera settings, or even when combining data from various cameras. All that can be compensated by the automated color balancing. So as soon as this color balancing result is available, then the operator can adjust the radiometry of the entire image block, or if needed, fine-tune the radiometry of single images. And the results of all that are presented in a preview ortho to the user so that an easy quality control of the full image block is possible. The next step in the workflow is then the processing of the so-called base layer. This is a low resolution DSM and ortho again, similar to the output of the radiometry stage. And this allows to verify the stage of the data, to verify all before it goes as input into the high resolution processing and before a lot of processing power and time is invested. At that stage of the base layer, there is the editor for the water mask and the water levels available as well. So based on the base layer, the user can select regions of interest which should be processed to high resolution. So either the full data set or just a selection can be processed. And the high resolution processing can create the DSM, the DTM, the DSM based orthophoto and the DTM based orthophoto. So also at that stage there is this editing of the water mask and the water geometry available. So this might be useful in cases that there is a large body of water, a sea or a lake, where the water level needs to be adjusted. So if that adjustment is done, then only for these affected tiles the reprocessing is then started. So this is then handled in a very efficient way so that no double reprocessing needs to be done. And then on the other hand, high resolution data can be edited as well. So we provide the height field editor, which allows to interact with the DSM and the DTM at full resolution. And for the orthos, we do provide a seamline editor to modify the cut lines in between the single rectified images for the orthomosaic at full resolution. And then now with version 6 there's a new blending mask editor available, and this is first applied to water only. So seam lines on water bodies are blended to make their additional homogeneous look for the orthomosaic on water, and if needed that blending mask could also be applied to certain regions on land. So that's it for this first overview. Now I would like to switch over to the demo of UltraMap version 6.
So let's jump into the demo of UltraMap version 6 and have a look at some of the new features. The workflow within UltraMap version 6 remains unchanged until the error triangulation stage. But then, starting from here, from the bundle adjustment result, then the new features for handling the water bodies become active. So first, there is an automated detection of the water. And then, based on that mask, the software tries to automatically derive heights for the water bodies. So the levels of the water are estimated automatically by the software. The main window here shows us this mask, which is including large bodies of water here on the east side of the project area, but also smaller bodies of water like swimming pools, ponds, or fountains. This mask can be activated and deactivated, and we can also switch on the DSM, where we do see already the water bodies as they have been flattened automatically by the SS on the one hand for the water height. This automated estimation of the water height is based on an analysis of the shorelines and is typically good enough for the color balancing and for creating orthomosaics. There might be cases where the water is estimated incorrectly. And for these cases, UltraMap offers some editors to interact with the data. On the one hand, the mask can be modified, and on the other hand, the water height can be edited. So let's have a closer look at this data set here. This is data from an UCO 4.1 captured in Barcelona, Spain, with a ground sampling distance of 7.5 centimeter. The forward overlap of this data set was 80% and the sideward overlap 60%. So here we see now a huge part of this data set in the 3D editor, where we see a low resolution DSM and the body of water with the overlay of the mask. Now the mask deactivated, so we see here the height of the water as it is in this low resolution DSM derived automatically by the software. So in case that something went wrong with the automated detection of water, there are a few ways how to interact with the data. So first, for the mask, we can use these tools here to modify the mask, so to create some areas to be included in the water mask. So now this polygon here is considered to be water as well. Of course, this is not correct, just to show you this with an example. On the other hand, we can also modify the height of the water. So if you have project requirements where a specific height of the water level should be applied to be used in the DSM, then this can be done very easily with the tools that we have now available. So we use this height brush here, and for my data set, I know that the water level should be 15 centimeter. So now I can draw a polygon around all of that here. And now all of the area which is highlighted by this greenish color, for all of this area, this height of 15 centimeter for the water is applied. And please note, the shoreline is taken into account. So the classification data, so where the water was detected by the software automatically, only for that area the height is applied, but not for the other area, not for the land. This is an incredibly efficient approach because the operator does not need to digitize the shoreline in a manual way, but can rely on the automated extraction of the shoreline and then only do QC and edit the shoreline in case where needed. But otherwise, all this work is done in an automated way. So now switching off the auto overlay, the mask overlay, and this edits overlay, then we can now go back and forth between the original version where water height was estimated by the software, and then after our edit, and we can see that there is now a perfect water level as it is applied to this data set. With just a few clicks, this huge body of water with a very complicated shoreline in this harbor area was modified. And all these modifications are done on low resolution of the orthophoto and low resolution of the DSM. The reason for doing that on low resolution is to make it possible to interact with the data at very large scale. So huge project areas can be loaded into this editor, can be viewed, and can be modified in that way. And doing that in low resolution has the benefit of fast interaction with the data for the user and reduced consumption of processing time. So all this is streamlined to get the data ready for doing then resource-intensive processing on high resolution. Next in the workflow comes then the automated processing of the color balancing. The color balancing tries to minimize differences in between neighboring images. So these differences could be because of different day or time of the acquisition, changing camera settings, or in case of water bodies, due to reflections on the water which change as the aircraft is moving. So therefore camera shot positions are moving and reflections over water change. So here we see now the result of this color balancing with nice homogeneous colors on the land and on the water. In the new version 6, there is not only color balancing for the land areas as it was in previous UltraMap versions, but now color balancing is also done on the water bodies. So this is on the one hand possible due to now a good height information. So the DSM as we have seen it before with flat water level, and on the other hand some adapted algorithms for the water area. To give you an idea of how much the algorithms do to the images, I switch off now the color balancing and we see now the unbalanced orthomosaic. So clearly visible are on the water the flight lines in north-south direction, on the one hand with differences in between the flight lines in terms of the reflections, and also with differences within flight direction. So all that is compensated well by the software when we switch to the balanced version. Again, now going for the unbalanced version, we clearly see these differences, and here they are compensated in a very good way. The results are shown here on the low resolution orthomosaic to make it easier for the user to interpret the results. However, the software is always applying all these modifications to the single images in the background. I would like to show you now another dataset where these new features worked very well. So I'm switching to another instance of UltraMap Studio. And here we do have a dataset from Jacksonville in the US, also captured with an UCO 4.1. And here we see the water mask as it was captured or detected automatically by the software. Also here, very successful automated classification of the data. Then based on that water mask, the DSM was derived, and that DSM was used to do the color balancing. So here's the result of the automated color balancing. And now switching to the unbalanced version, we see that there is one line in north-south direction, which is very bright compared to the other parts of this project area. Bright on the land and on the water. So this was obviously due to changed camera settings during flight. So not so much because of reflections on the water, but rather because of other influences. And now switching back to the balanced version, we see that there was a very successful compensation of these effects in the input data for the processed results. In case that the automated classification of the water does not work as well as we have seen in these examples, you can use the editor for the water mask as we have seen before, or alternatively, you could also import some external data. I would like to show that here with the example of Venice. So Venice is very challenging with regard to handling the water bodies for the processing. The automated classification works well for the larger bodies of water, also for some of the small canals in here, but it might struggle for some of these very, very narrow and small canals. So to be able to handle such a project area in an efficient way, we offer an option to import data. So to import an external water mask, and we did that for this region here. And here we see the display of that vector data. So for this example, the data comes from OpenStreetMap. The import supports either 2D polygons, so just to replace the classification data, or it can read 3D polygons to also replace the water geometry. For the next processing stage, let's go back to the dataset of Barcelona. So here we are now in the stage for the DSM and auto processing. And there is a new user interface to this component of UltraMap Studio. So on the one hand, the elements of the ribbon have been reorganized. And on the other hand, you find now here on the right side a menu bar where all the layers can be activated and deactivated and controlled with adjusting transparency and so on. Besides the user interface, we did also significantly enhance the data visualization performance. So instantly you can zoom in to the full resolution of all of the layers. So without any delay, without waiting for loading the data, you can activate or deactivate layers and zoom in to full detail. This improved performance is not only available for this viewer here, but also for the height field editor. In the height field editor, you can load the DSM and DTM at full resolution and interact with the data, so modify with any of these tools. So these tools have not changed with comparison to UltraMap version 5, just the speed with which you can open and interact with this editor. This has been changed for version 6. Back in the main window, you can switch easily between all of these layers. So now we see the DSM-based orthophoto, the DTM, and the DTM-based orthophoto. All now is instantly being updated here in the viewer thanks to this improved performance. For the orthomosaics, there is now a new feature available, and that is blending along the seam lines over water. So here we see the blending mask. The blending mask is per default identical to the water mask. So for all bodies of water, all the seam lines are blended within a certain corridor to hide differences in between adjacent images and to make a nice homogeneous mosaic. So this is one of the steps to improve the orthomosaic on the water. The blending helps to improve the seam lines on the water, but it can also create some new challenges. So here, for example, we see a boat which is near to a seam line. So the seam line is just here, and that boat is within the corridor where blending is applied, and therefore the boat is textured in this orthomosaic from two images. Therefore we see there a double structure. This issue can be handled by modifying the blending mask for this particular region here. So let's activate the blending mask editor and then select the background tool. So background to tell the software that in this region here we do not want to have the blending mask, but the opposite, no mask, no blending to be applied. Then we apply this edit, and here we can see now this little job to be processed, and then we will see the result. So here is now the result. So just one boat is in the orthomosaic visible. So that was before the blending mask edit. We had here two boats, and then after this simple edit, there's just one boat left. So this blending can be used on the one hand on water bodies, but on the other hand, it could also be used on land to modify their certain regions. So this is now a new feature being available within UltraMap version 6, both for water and for land areas. So until now we have seen examples for flat bodies of water, so sea or lakes where there is no slope in the water surface, but of course there is flowing water as well. And for that I would like to switch to another example, to the city of Graz, where we have the river Mur, and there is a slope in the water surface which we need to take care of. This here is the low resolution DSM with the low resolution ortho and the automated result for the classification of the water and the automated estimation of the water level. So let's have a look on this in the 3D water mask and geometry editor. So looking on this river here in detail, we see there is well, quite nice reconstruction of the water surface, but it is not always as you would expect water to flow. So this has the reason that on the left and right hand side of the river there are a lot of trees, and therefore it is quite difficult for the algorithm to analyze the shoreline and to detect the water height correctly. The water can be adjusted with a few simple edits. So here in the lower part of the river we know that there is a water level of 388.5 meter. So I apply that height to the river here. So for this area there is a constant level because there's a dam just to the south of that part here, and therefore there is no slope anymore. Here in the upper part, around this artificial island here in the river, there is a height of 391.5 meter. So I apply that here, and then I use the height tool to create a plane with a slope. So clicking here 3 points and then applying that to that area of the river here, and now we do have the slope and new heights being applied to the river. So that was before the edits, where the water was flowing somehow in between the trees, and then after the edits it's perfectly flat, and it is also respecting the slope of the flowing water. So with that, I'm at the end of this demo, and we are now available for questions, and I hand back over to Alexander. Thank you.
Bernhard, thank you very much for this great presentation and demonstration. Ladies and gentlemen, we are now opening up the floor for questions and answers. If not already done, please be so kind and type your questions into the Q&A pane of the software system, and Bernhard and myself, we will be happy to answer all your questions online here.
Excellent, great. Hello, everybody. I hope you guys can hear me. We have already questions in the Q&A pane. So I'll start with the first one. Can UltraMap version 6 work with any data? The answer here is no, it can't. It is tailored to UltraCam, so the UltraMap, the full suite, can only deal with the UltraCam data, and it's a combined system of hardware and software. So UltraMap delivers stunning results because of the great input of the UltraCam with all the metadata information we have from the camera system. Next question is, we have a requirement to produce non-color balanced ortho output. At which point in the flow line would you recommend we create the base layer ortho? All right, Bernhard, that's a question for you. Could you jump in, please, and answer that?
Yes, so this use case is well supported by the new version of UltraMap. So in that case, we would recommend that you first do the color balancing as if you would do just a production for one version of your data. Then you go for the DSM production, so DSM processing at high resolution. And that DSM, that is then the starting point where you go into the one direction with a color balanced orthophoto and into the other direction with a non-color balanced orthophoto. So going for the first one, color balanced orthophoto, this is like the default path to continue in the software. And then for the non-color balanced orthophoto, we recommend that you take the radiometric settings from an early stage in the workflow before the color balancing, transfer that via the radiometry archive to this DSM stage, and from there start the processing of the orthophoto at high resolution with using this radiometry where no color balancing has been applied. In that way, you have first one consistent workflow to produce a consistent DSM for both versions of the orthophoto, and then you split up to get these two results.
Great, thank you very much, Bernhard. All right, so there's another comment which is very kind. Congratulations on the improvements, impressive. Hey, thank you very much for this kind comment. Highly appreciated. And then the next is again a real question: can UltraMap version 6 open version 5 projects? I would say yes, but I'm handing over to Bernhard just to make sure that the correct answer is correct.
Yeah, so as we have shown in this demo, there are some significant changes in version 6 regarding the data structure to enable, on the one hand, all these new features, and on the other hand, to enable the improved performance for the visualization of the data. This makes it necessary that data structure is being changed from version 5 to version 6. Also from previous versions of UltraMap. That means project files cannot be opened directly in version 6, but for earlier versions of UltraMap, we offer the way to import the level 2 data into version 6 and also read the error triangulation archive files and the radiometry archive files and use these in version 6. So using that path, using these imports, you get exactly the same results in version 6 if you would be processing with version 5, and you can also take advantage of the adapted data structure with enabling improved visualization performance and so on.
In which module is the water treatment done?
Yeah, so this handling of the water bodies is done in a number of modules. So starting, let's say, in this UltraMap Essentials package, so the very base module where the water handling is already done before the color balancing and then throughout the color balancing step, and then going up to the dense matching module and the ortho module. So in all of these, there are features to handle the bodies of water to optimize the output of these modules.
Perfect. Great. Thank you, Bernhard. Next one is, are there any plans to introduce more radiometry tools, specifically tools that affect color saturation levels?
Yes. So right now we are working to finalize UltraMap version 6 and provide a release and the next release shortly. And then after that, one of the next big things to work on is radiometry tools where some enhancements are to be expected.
Perfect. Great. Thank you. I'll give just a few more seconds to see if we have new questions coming in.
Are there, the latest one is, are there plans to open UltraMap for other cameras too?
So this is an ongoing discussion internally. We are trending towards potentially open it up, but we have currently some other developments going on. So that decision has been postponed, and I can for the time being not give a precise and definitive answer on opening up UltraMap for other cameras. Is the water handling color balance available to third generation cameras and the UltraMap Essentials module? Bernhard would love to hand this question over to you.
Yes, so all these features that we have shown are available to all UltraCam cameras. So starting from UltraCams from the very first generation up to the brand new cameras of the fourth generations, all cameras are supported. And yes, UltraMap Essentials module, that does include some water handling features as well as all the other modules. So depending on the module where the license is available for, you get the water handling features which are important for that module.
Great. Thank you, Bernhard. Then a question which is probably tied to it. Can this handle multispectral or thermal image input? And
sorry, go ahead.
Yeah. Now, first of all, it can only handle UltraMap imagery. As UltraMap is not collecting any thermal data, that means that the whole UltraMap suite cannot deal with any thermal data. And with respect to multispectral image, Bernhard, probably you can add some color to that.
Yeah, so UltraMap is optimized for UltraCam cameras, so we can work with data from any UltraCam, but there is not support for data from any other cameras.
Another question is there a release date for the full version of 6.0? So the release date of the software?
Yeah, so we do not yet have a clear date when the release is going to be. The goal is to have this full software version available around end of March, beginning of April.
Great. Next question. Generally, how accurate is the estimated elevation that water handling creates?
Yeah, so this is a very good question, and this depends on a number of factors. And probably the most important is what is around the water. So as we have seen in that example from Graz with that river, there are a lot of trees on both sides of the river. And in addition, there are a lot of bridges. So the classification of the water is very successful with detecting the water body reliably. But then at the edge of the water body, the DSM is analyzed. And the DSM in that case gets a lot of height information from the trees and from the bridges. Therefore, the water level is too high in some places. And therefore, the editing was done as we have shown in this example. However, of course, the need for the editing of the water body, that depends on the use case, what you need the data for, and what are the requirements for this use case. So not in every case, of course, such editing has to be done.
Good, perfect. Thank you. Next question is, can water handling create polygons to be exported out as shapefiles?
Yes, so the water classification is an internal process where you can see then the mask within UltraMap Studio and use it there. And then for various use cases, you can export that mask either as a raster or as a vector dataset.
Next question is there a strong quality loss of water detection with lower resolution data, for example, a UCE flight with 20 or 25 centimeter ground sample distance?
So the detection of water is as good as the image, the input images are providing the information. So in case of input images with 20-25 centimeters, then that would also be the resolution that the detection of water is being done. In general, the algorithms that we are using have been trained with a great variety of input data. That means we have been using data ranging from a GSD of about 3 centimeter up to about 50 or even more centimeter. And not only that, not only this huge variation in terms of GSD, but also data from all continents and data from various camera models. That also means various focal lengths and so on. So we try to get the biggest possible variation to make this procedure as robust as possible.
Great. Next question, has the DTM classification in high relief areas been improved in version 6? In version 5, we are seeing ground data being removed in the DTM that was probably classified as ground in the DSM.
So in the upcoming release, there's not yet an update to the DTM algorithm, but for the release, which comes then next, this topic is top on our list. So yes, there will be something to be expected quite shortly.
That's great. Next question, can the radial radiometric tool be used in another shape other than a circle? Can long/narrow areas be adjusted rather than large radial areas?
Yeah, so this tool, this is a very specific question to one of the tools of the radiometric adjustment module. And this tool, which is asked here, this is not yet modified here, but yeah, we do have already plans to do that as well. So midterm, there are some changes to be expected.
Good. Next question, can shapefiles or vector data be loaded in UltraMap Studio Basics before AT, TP, CB also processing?
Well, so at the very beginning of the workflow, there is currently no import of such data supported. At later stages, yes, their data can be imported. So it depends clearly on where to import what kind of data or information. So we can discuss that afterwards also in detail, so just reach out to me, please.
We already have a restricted area option that excludes the inside set area. Do you plan to make the inverse available? For example, export the inside of, for example, a shapefile?
Yes, this can be done. So for the detailed steps for how to implement such workflow, please reach out to me and I'm happy to guide you through that.
Great. I would like to thank you very much for the participation in today's webinar. I really do hope that it was worthwhile for you to attend. Also, thank you very much to Bernhard for the excellent presentation, and Angie and Kati and Eda and team for the preparation of this webinar. I really do hope that I can meet you all in person again soon. It was again great talking to you. Well, closing this webinar of today, and I wish you a fantastic morning, day, afternoon, wherever you are in this world. Thank you very much. Bye bye.
Thank you. Bye bye.